Good afternoon, everyone. Thanks for joining today's webinar, Creating Smart Intersections with Siemens Peer-to-Peer Networks. My name is Connor, and I'll be your moderator. A couple housekeeping items to run through quickly before we get going here. All phone lines are muted, so if you have any questions, please use the chat feature within the GoToWebinar toolbar. Presentation will last about 40 minutes or so, which will give some time for questions at the end. By attending today's webinar, you are eligible to earn TARP points through IMSA. If you went ahead and provided your IMSA number during the registration process, Western Systems will go ahead and handle that submission to IMSA for you. If you'd like a copy of today's slides, they are available within the handout icon on the GoToWebinar toolbar. And lastly, today's presentation will be made available on demand. You'll get a follow-up email tomorrow with a link to do so. All right, with the housekeeping out of the way, I'm excited to introduce today's speaker, Kai Antrim, Territory Manager at Western Systems. Kai, the floor is all yours.
Hi there. Good afternoon, everybody. Thank you so much for joining us for kind of this next in a series of our webinars. For those of you who haven't tuned in yet, we're passing the time of not doing in-person meetings by trying to set up as many remote presentations as possible. As much as we like to be out there shaking hands with you guys out at the intersection, working hand in hand, everybody's safety and health comes first. So we are abiding by those recommendations. Hopefully, I guess we've got people from all over the country tapped in right now, but things seem to be leveling off a little bit in Washington State. So we're really hoping that, in the next couple of months here, we can start thinking about things going back kind of to normal as we're used to it. But here at Western Systems, we've kind of been deemed an essential business in terms of operations. So we're taking the necessary steps to make sure that our people stay as healthy as possible. We're still doing all the manufacturing functions. Knock on wood, our supply chain appears to still be in pretty good shape. We're still producing product and able to get product from our vendors. So again, knock on wood, it's more or less business as usual with a lot more of these web cameras. So as I mentioned, I appreciate you guys tapping in for another webinar. Hopefully, maybe next week, if I see you guys for another one of these, I will be in a standing position. We've all got the okay to order standing desks, so it's been a lot of sitting for those of us who are used to kind of getting out of the office and being out and about. Little side story about me: when I was back in college, it brings me back to the days I was a blackjack dealer at a casino, and I stood all day long. If anybody's ever been to a casino, you stand there and you're schlepping cards for hours without having any break. And I told myself, one day I'm going to have a desk job. And I thought that's crazy of me to aspire to having a desk job. Well, I'm ready to go back to standing. The standing desk craze seems to be here to stay. So I'm looking forward to giving you guys a different view of my backdrop here. So without further ado, we'll go into our presentation today. We're going to talk about event-based adaptive applications using peer-to-peer, specifically with the Siemens traffic controller. But first, Squirrel Camera. I don't know what all of you guys are doing in your free time. If my boss is on the line, I want to promise that I did not set up the Squirrel Camera during business hours. This is a PTZ camera that Western Systems sells. I've got them set up in some of our salespeople's office, and since I can't be showing you guys a view of the traffic, and again, this isn't a presentation about PTZ cameras, but I did use my salesman carpentry skills to put together a life-size replica of a park bench, and I've got it trained on where my squirrels normally hang out in my backyard. And what I've done is I've masked the background, so any movement in the leaves behind there is ignored, and I'm able to capture some really good footage of these buggers in my yard. So if anybody wants to know more about how the Squirrel Cam's going, reach out to me after the show. How peer-to-peer works. So Siemens peer-to-peer within the M60 controller, It works on a subscription basis, subscription being each of the controllers are subscribing to each other. You can set up a network of up to 16 of these controllers, kind of all talking to each other. The max number of event subscriptions is 32. Max unique event publishings is also 32. But essentially, you choose a controller, you subscribe it to other controllers, those become the network of connected controllers. We'll go a little bit more into what kind of back-end software and stuff you need, but the important thing here is you often, and it looks like going down the list, a lot of people are already Siemens users. It turns out a lot of you probably already have the functionality out in your streets today to be able to do peer-to-peer, but might not even know it. Essentially, a connection is established during the subscription that tells remote controllers what you want to know from it. In short, peer-to-peer uses logic statements. So you're going to say, if this happens, then this happens. That's kind of the simplified version of this. The controller sends a message when a certain event occurs. Then the subscribing controllers are able to listen to those messages that come from maybe an upstream controller. Even if the event is not triggered, the subscribing controller is going to periodically send out a message to determine if the peer link is active. So you don't have to worry about going a long period of time without activating peer-to-peer and then all of a sudden wanting peer-to-peer to work and it not working. It's on a regular basis sending out messages to each of the controllers that it's talking to and saying, are you there? Are you there? Okay, good. Just making sure everything's good, our connections are good, everything else. Essentially, it uses TCP packets to send information. Peer-to-peer is a term that we use in connection to our Siemens controllers, but in short, it's just two computers talking to each other, sending back little packets of information. And when it comes to controllers, their information, it's nothing compared to the data required for sending back video or something. It's literally just small packets of information telling, this is what I see, and based on what I'm doing, I'm going to give you the command to do this. So in terms of increasing data on your network, it's not a big data hog to set up some of these simple logic statements. Now, as we've done with a lot of these webinars, we want this to be kind of an opener for you guys, open up your minds to the possibilities of what you guys can do with some of the equipment you already have out there. If you guys do, want a little bit deeper dive in kind of the programming and the networking of it, we're all super available right now, as you guys know, to do one-on-one webinars. We've kind of cast a broad net for these particular sales webinars to get the word out. But call up your territory manager or rep or your technician that you have a relationship with, and we'll walk you through specific situations. The idea here is, we at Western, we can't think of all of these ideas, but if you guys dream up, this is what I wish my controller had, or this is what we're getting a lot of calls on, at certain locations. Those are the things that we're going to be able to step in and say, okay, from a programming standpoint, this is pretty simple, or we're going to do this, or it's not that simple to do this, but here's our recommendation. So I'm just going to go really quick through, the basic setup of it. You can do it all locally on the front panel of your controller, or you can do it from a central location if you have that capability. But first, we're going to go into the active status menu, communications. Essentially, what you're doing is getting the controllers to talk to each other. So within the communications menu, we're going to go define the IP address for the peers that you wish to subscribe to. So you're essentially going to start from a certain location. You're going to go in and you're going to configure that location's IP address with all of the peer controllers. You're going to configure sources. So here we're going to assign the peers and establish a connection with the peers. We're then going to get a feedback that says, okay, there's a successful connection established. Here are the functions that we want to assign. In other words, we're going to configure the data that we want to get back from the peer. I want to be careful because, we talk about all of the capabilities of the Siemens M60, but this isn't something that just gets turned on. Sure, all the functionality is available out of the box, but this is where, when you're doing your intersection turn-ons, or you're talking to your technicians, or talking to us about your signal network, we're going to say, what in particular do you want to do at this particular location that's maybe outside of your normal phasing and timing plan? That's where peer-to-peer really is powerful in the Siemens controller. Source status, again, at any given time, you can go in. This is going to provide you of your peer-to-peer status. So although the system in and of itself is on a periodic basis checking the status. This is in the peer-to-peer status menu. You're able to go in there and manually check to make sure your controller is talking to everybody you want it to be talking to. Function status, that's where you're going to look and confirm that any changes that you made or any any thens in the if-then statement have been properly programmed, and you can see the status of those functions. So if this, and I realize this might be a little bit archaic for somebody who's not familiar with peer-to-peer, but we'll go into some real-world examples. But essentially, we're trying to set up situations where if a certain event occurs, it creates downstream or upstream events in order to more safely move traffic through the intersections. So event-based controller applications. Some of the things, and we'll go into each one of these a little bit, but some of the things that peer-to-peer is able to do is deal with oversized pedestrians. In short, pedestrian crossing times are different than vehicle times. We need to give pedestrians longer to cross the street in some circumstances, whether it's just a generic intersection or you're by a school or a nursing home or somewhere where people are moving slowly. This is where the dynamic functionality to custom suit pedestrian needs is going to come into play. School zone safety, again, we're talking about kids, we're talking about time of day planning where you're getting a big flood of vehicles on otherwise quiet intersections. School zone safety, a lot of applications for peer-to-peer there. Green band optimization, so moving vehicles in a green band is a lot more efficient than we've all been in the car before and said, oh my gosh, the second I get to go at this intersection, the next intersection on the corridor is red. In terms of reducing emissions, increasing travel time reliability, there's a lot of things we can do in peer-to-peer on a local level to create green bands. So along our major arterials and without sacrificing, our side streets, we're moving traffic through in platoons, a little bit more efficiently. Ramp queue management, this is a big one. There's a lot of ramps going onto freeways or onto larger arterials. We want to make sure we're not backing up ramp queues and creating potentially hazardous situations. Minor intersections, you might be wanting to run a main street and free, but you've got a minor intersection nearby. You want to trigger an event on the main line to take into account when you do get traffic on minor intersections. Heavy rail preemption. We'll talk a little bit about using the priority and preemption features that we normally associate with emergency services vehicles and buses and things like that. But we still have that functionality in the controller that gives us more control over certain situations as they may arise. Assigning pedwalk to trigger priority routines. So, as I mentioned, pedestrians have different needs, and when it's a car versus a pedestrian, we know who normally, quote unquote, kind of wins that collision. So what we want to be able to do is, when we do have pedestrians, can we trigger a routine that is different than your normal vehicle phase? Vehicles have different needs than pedestrians. When we've got somebody there or a big group of pedestrians there, we want to be able to trigger a routine that's maybe going to extend that phase. We're going to say, okay, we want to give more passage time for this particular movement. It's the same thing in the controller that a priority routine is doing, but we're driving it off of an assigned pedwalk phase. We also have the ability to reduce split timing of unassigned phases. Trigger priority event based on oversized PED. So this is just your Siemens assigning function screen. This is where our source function, when we get a PED walk, and then what we're going to, that's the if statement is the PED walk signal comes up, and the then statement is the priority on that particular detection input. So essentially what we're doing is saying, it's not based on time of day, it's based on actual events that are happening. When this comes up, we want to trigger this. Another example of using peer-to-peer, you can actually peer to yourself, and if that's confusing, it sounds confusing. It was confusing to me at first, but in terms of using this functionality in the controller to give different, assign different functions back to the same controller. So an example of where you might do this, we've all seen these flashing yellow arrows come up. Well, the traditional treatment of the PED signal, the PED movement that would conflict that left turn is to omit the flashing yellow arrow when a PED comes up, when the PED signal comes up. Well, the reality of it is maybe there's enough time to still give that flashing yellow arrow after the PED's gone through. You've moved the pedestrian safely through the intersection, but there's there's got to be a way to trigger that flashing yellow arrow to come back up. So in peer-to-peer, one of the applications we've done is we've assigned a dummy detector. We put a dummy call into the controller after that ped walk goes down. So the pedestrian safely crosses. You'd have a red, you've got a red arrow for the left turn movement. Maybe it stays free there off of the main line. We don't want that to become a flashing yellow arrow where people are trying to sneak across traffic or sneak in between vehicles and potentially create a dangerous situation for that pedestrian. So what we're going to do is we're going to wait for that ped clearance to go down. We're going to place a dummy call into the controller that says, okay, if there's enough time on that phase after the ped moves through, we're going to bring back up the flashing yellow arrow for the rest of the split time. Adaptive school zones. So in and around school zones, loading in special functions to different phase banks to drive traffic patterns in and around schools, depending on whether we expect school traffic to be in session. So whether that's specially placed detectors, whether that's tying into nearby hawk signals, adding extension times, certain times a day, peer-to-peer allows us to send information to nearby intersections and essentially make our school zones a lot safer. Green band optimization, so setting priority routines, platoon detection. So platoon detection, the idea there is it's great to just see one vehicle, but if we can maximize the size of the platoon, then create a green band for them so they're all moving through the intersection. Again, peer-to-peer, it benefits from having good, reliable detection, whether that's just for stop bar applications or advanced detection that's really able to capture that platoon. What we want to do is create a band, as I mentioned, down that main corridor that captures as many vehicles at the time as possible, so we can reduce the number of arrivals on red, increase the number of times that you're rolling up to that intersection and the green turns green just in time. One way to do that is make sure your controllers are talking to each other and have good logic statements put in. As the platoon gets to this size, we're going to put a priority routine to move this big group of vehicles down a corridor. So downstream intersection, early return to green, downstream intersection using peer-to-peer, it can trigger a priority routine if necessary. Again, this is a snapshot of the front screen of the controller when you program an event like this. So this is the source function is when the phase is green, and then the then statement is prioritized detection on the downstream intersection. So essentially, what we're doing is we're using a controller. Let's call it controller A, and we're going to be able to tell controllers B, C, D, however many you want along that corridor to put in a detector call. So you're giving it a heads up. We've got a lot of situations where agencies, they don't have advanced detection because their intersections are a lot closer than you potentially want it to be. Well, we can use the detectors at upstream intersections to essentially cascade down and in some cases preclude the need for detection in those areas. Ramp queue management. So this is a little bit of an infographic here on a situation that we don't want. It actually looks like traffic is moving pretty swiftly along the freeway. Well, we've created a situation, be it with a ramp meter or whatever else, that we've got a backup of traffic. If there's any turns coming onto this on-ramp, we've created a dangerous situation that could possibly cause rear-end collisions. Preempt, we normally as traffic people think of preemption as used for emergency services vehicles and immediately changing the traffic flow to get our fire trucks and police cars through the intersections. Well, that functionality is very useful in peer-to-peer to prompt certain routines. Although we're not trying to get an ambulance by all these stopped vehicles here on the on-ramp, it is a good idea to reduce collisions to flush that on-ramp. So we're going to peer the adjacent signals and say, hey, when we've got this backup of vehicles or this platoon of vehicles coming your way, we need to preempt this ramp meter and make sure that people are flushed onto the freeway, in a safe manner, so as not to back up into the main line and the side streets there. So, and then peer-to-peer also gives you the ability to quickly jump back into coordination without losing a bunch of time in transition or whatever else. This is again the front screen of the M60 controller. It's showing the functions that you would assign to back up a car trigger preemption event on a ramp. Adjacent signals, they're going to get preempted too, as needed and as programmed by the user or by the agency with the help of Western Systems. Will help you set up. Okay, if this gets backed up, what's the most efficient way to move traffic swiftly to avoid a potentially dangerous situation? Minor intersections. So on your non-main corridors, setting priority routines, set minor intersections into free. Maybe a free operation is a more efficient for whatever use case you have in front of you. Use priority routines to force off minor intersections. Turn these minor intersections into a green band. Similarly, we talked about moving platoons through. Heavy rail preemption. So, this is a big one when it comes to safety concerns. We've got Burlington, Northern Santa Fe that kind of goes right up and down the West Coast here, and some east-west heavy rail movements. So the idea here is a preemption event. It's not necessary to put a true preempt call from the train into every signal. We can get each of these controllers talking to each other and sharing information about those preemption events. So maybe you've got your preemption, your Opticom, or whatever it may be at one of these intersections, but you want to also drive the behavior at these other 4 locations. Well, we can program using peer-to-peer set up preempt calls. Peer-to-peer reports. So this is your report menu. It's going to give you the month and day, obviously the time. It's going to show you all of the peer-to-peer events that may have happened. So you want to look in and see how effective is my programming? What's the status of my peer-to-peer network that I've set up? Right from the controller, you can download it as a YAML file, or if you're using tactics, you'll be able to pull back that information and really get a feel for, before and after you put this peer-to-peer, how effective is it being used? How often am I triggering events? And then maybe make some changes as you might see necessary. So I'm going to talk a little bit about a couple hypothetical use cases. Those are the ones that kind of make most sense to us, and maybe get your guys' heads working on some potential applications in your agency that might be able to benefit from this. Again, it does take a little bit of programming. It's very simple once you get the feel for it. And our techs, each of our technicians, we've got 5 up and down the West Coast. They're really good at setting up peer-to-peer, just given the information of the situation. So you can say, I don't exactly know how this works, how the peer-to-peer is set up. I don't want to, but we've got a situation where, we're trying to flush people off the freeway or whatever it is. So I'm going to try my best here to give you guys a visual idea of some of the things that this is able to do, and go into a couple more use cases. In this particular situation, Highway 100 runs parallel to Mall Boulevard, and as Mall Boulevard indicates, there's a large shopping area that we're trying to get people from the mall to the shopping area and vice versa in a safe way. We don't want a situation where vehicles are backing up onto the freeway and you've got a situation where people are going 70 miles an hour and then forced to make an immediate stop. So it's important in these situations for the safety of our drivers, pedestrians, everybody on the roadway that we're able to determine the potential destination that people might be wanting to travel and set our traffic signals up in a way that moves them there more efficiently. So our red, my little red markers there are going to be phases that we set up to be omitted. So when we get detector calls, or when we detect presence of people on phase 1 there coming off the freeway, we're going to try our best to move them over to the mall, which is 2 left turns by locking the detectors that correspond with their movements, and then omitting the phases that would otherwise be conflicting with those movements. So our if statement is if phase 1 is green, then we're going to omit certain phases and we're going to lock certain detectors. So you can see, I hope that's a good visual there. Phase 1 on the highway there is the left turn movement towards the mall. Phases 4 and 7 are your through movement and your left movement to get to the mall. So we're going to try and flush people off the freeway, move them over to the mall, and omit these phases that are less important. We're less concerned about backing up traffic because we're more concerned about the safety of people coming off of the highway. So that's a hypothetical use case scenario. I'm going to talk to you about a couple of real life situations where we had opportunities to use peer-to-peer to increase safety. One of the places that I don't know if anybody's tapped in from Coeur d'Alene, but Coeur d'Alene has been doing a lot of cool things lately in terms of upgrading their communications network, their traffic controllers, just about everything they can to move traffic more efficiently. And one of the things that they've tapped into here is they've upgraded their controllers to M60, Siemens M60s, is used peer-to-peer for certain situations. So I might have glossed over a little bit of the key facts. So although this is specific to Coeur d'Alene, there isn't, I want to go into a little bit the hardware required for setting up peer-to-peer. Now, peer-to-peer has the ability, it's just two computers talking to each other. So it doesn't require a central system. You know, as much as we think that, you know, most agencies that we do business with could benefit from having, you know, a tactic system where everything's coming back to a central location, gives you the ability to see your camera, see your controller data, have control of your entire network, you know, in one location. That might not always be possible for some agencies. And kind of what I really want to hammer home here is you can do a lot by having controllers that are talking to each other. You know, they need to be connected via some sort of Ethernet or serial connection. So while the limit of Cat5 cable is about 300 feet, you're not going to be able to run Cat5 between controllers in a lot of situations. This is a great use case for wireless radios. You could do it with cellular networks, whatever you know, your agency is comfortable with. You just need to get controllers that you want to be doing peer-to-peer with talking on the same network. From a controller standpoint, you do need a Linux-based controller, I believe, and I'll double check this, but you've got to be running 358 or above in order to have this functionality. It needs to, you know, be using a Linux processor, so you can either be running one of the upgraded M50s. Lots of M50s out there running OS 9. Western Systems offers a upgrade kit that doesn't require you to replace the entire controller with a brand new controller. We just swap out the old operating system card, and we upgrade your power supply, give you a new front panel. Essentially, you get a brand new controller with all of this functionality without putting in a new controller. So certainly an upgrade path. And if you do have M60s like Coeur d'Alene has on this network, I'm going to talk a little bit about. You've got all of that functionality at your fingertips. So for this particular application, we were using Intuicom radios operating on the 4.9 gigahertz spectrum. So those are broadband radios that are capable of up to 1.6 gigabits of throughput, but you don't need anywhere near that for running peer-to-peer. But the important point is these are just wireless radios. They don't have a central system yet that they're bringing all of their information back to, but they did find this way to set up communications. Each cabinet had a rugged comm switch, which Western Systems was able to provide. This particular use case, they had a situation where they wanted to drive certain behaviors when there were certain vehicle movements, and we were able to set that up for them after going out there, doing a site survey, and seeing what they need. Another thing was they were able to tell us, here are the predictable traffic patterns. You know, there's a trail here, and there's a you know, this is the main thoroughfare where traffic is going, and that makes it a lot easier because after finding out the lay of the land, the logic all kind of takes care of itself. So real quick, I think you guys can see my arrow, but it's industrial loop here, right in the middle. This is a big industrial park. So not only do you have a lot of workers coming in and out of there every day, kind of throughout the day with heavier flows certain times of the day, you've also got big heavy equipment vehicles that you want to you know, make sure you're giving it enough time to get safely through the intersection, but also not creating dangerous situations for you know, the nearby roadway users. This particular, if anybody's familiar with the Centennial Trail that runs in northern Idaho, it's got a hawk signal there. I don't know if anybody can, I'm sure a handful of you can tell me what a hawk signal stands for, but it took me forever to realize that you know, traffic acronyms are very, very funky, and somehow you got Hawk out of high intensity crosswalk activated beacon or something like that. Somebody was deciding, you know what, that's way too long to say. The acronym doesn't sound good. We're just going to call it a Hawk signal. Maybe somebody after this can tell me why it actually received that name. But anyway, I digress. So coming off of industrial loop here, you've essentially got two movements. The main movement is going to be southbound towards Kathleen Boulevard. Greenwich turns into Kathleen here. That's going to be your main traffic movement. But if vehicles do opt to turn left and head north, on Atlas Drive here, we've got the Centennial Trail, which has got bikers and walkers and joggers, and there's a Hawk signal there. So we want to be careful that we're not creating a situation where we've got heavy trucks flying around the corner when this movement here has a green light. So I'll toggle back and forth between this slide and the next slide, but I want to give you guys a little bit of a visual for what's actually happening out on the street. This is not a traffic signal pole created by Western Systems. We try and be a little bit more sophisticated in our design and not have any contractors install them in people's front yard. But this is the best I could do working remotely, and the darn Google Streetcar hadn't been out to Coeur d'Alene since we put in this intersection. Anyways, this is a T intersection. It's a one-phase intersection. So what you have here is phase 8. You guys see here, that's this phase here that's turning north and south. That's T intersection. Hope I didn't go too fast there, but we've got wireless interconnect going both directions, up and down Atlas Boulevard here, and this is the reality. I do have some real life pictures. Ryan McKibben, our fearless tech, was out there in sub 20-degree temperatures. For those of you who are familiar with Washington State, we've got just about Washington State, the Pacific Northwest, we've got every single weather pattern you can imagine. You know, it can be sunny over here and you can be swimming in the ocean, and then over there in Idaho and Coeur d'Alene, we got an absolute blizzard. So kudos to Ryan for being out there and getting us some of these pictures. But as you can see, we've got our advanced detectors here on industrial, and also our Intuicom radio shooting back. So phase 8 is the movement onto the T intersection. And then here is an image of the crossing where the Centennial Trail comes through. At least I had some mast arms to work with here with my graphics. Couldn't find an Intuicom radio picture that was shooting the right direction, but please just imagine that that's shooting towards us down Atlas Boulevard. Again, we've got a Western Systems cabinet and an M60 controller. And then the view the other direction down towards Kathleen, this is the main vehicle movement. So phases 1, which is the left turn movement off of the main drag, and phase 6, which is the through movement. So hopefully everybody has digested that all. I'm going to jump back here to this infographic. So we have vehicles on phase 8 going down industrial loop, and when phase 8 is on, what we want to do is we want to omit the phase, just a single phase Hawk signal here. So when phase green on, omit here. And in layman's terms, what we're trying to do is prevent a green light where vehicles are flying around the corner while pedestrians have pushed the push button. They think they're in a safe situation, and there's a potentially hazardous situation. So while this phase comes on, that's what we're doing over here. Down here, the goal is to flush people onto Kathleen Ave, which is kind of the major arterial in and out of this kind of neighborhood mixed use area. So what we're going to do is we're going to place calls on 1 and 6 when phase 8 comes up at that T intersection. So in other words, what we're doing is we're giving this intersection down here a heads up. The vehicles are coming. You can see we've got a vector, an Iteris vector detector looking down industrial. It's able to get us, tell us how big our platoon is, and it's going to place calls based on vehicles being sensed with the detectors here, and it's going to say, hey, just so you know, Kathleen and Atlas, we've got a group of cars coming here. We're going to place this call before it would otherwise be placed. The alternative would be waiting till you're hitting these stop bar detectors after these have come around, and then you've created a very, very slowly reacting system. This gives us the ability to, again, peer-to-peer, we call it a local adaptive. It's giving us the ability to make these things happen one step ahead of time as they normally would. So that's the Coeur d'Alene use case. So we talked about the ability to use preemption to flush vehicles off of on ramps and things like that. Well, how about actual preemption in fire trucks? So in this situation, and this is not an actual, I don't believe they have peer-to-peer set up here, but this is a use case that I had to come up with where the fire trucks are leaving in a hurry, getting out of this fire station. On the left here, you see the Opticom emitter, and it's sending that signal to the intersection. Well, once you get to this intersection here, you've got the option of going left or right, and then you have another intersection there. So instead of waiting for that vehicle and its preempter to see that fire truck coming, why not send a cascade of preemption calls down the corridor that you know that vehicle is going to be traveling? So you've got a left turn here, so you can set up a detector here, and you know that he's turning left, and then we're going to preempt that signal down the way. This offers you a fail-safe for your Opticom. I mean, your Opticom, there's a number of different flavors out there, but if you're using infrared sensors, we all know we need line of sight to that next one. How about letting the controller do the work for you? And as long as you've got good, reliable comms, it's going to send that preemption signal down so that that intersection can operate in a safe manner and be more responsive to that fire truck or emergency service vehicle's need. We've all seen, the fire trucks come barreling down into the intersection, and you can almost see the look in the guy's eyes as he's driving, saying, "Come on, signal, get working." Well, this creates a situation where you can have those preamps work a lot more efficiently. Likewise, this is a T intersection, so if you're turning right, for any of you kind of in the Washington area, this is right outside the road at Western Systems. But if you only got two directions you can go, left or right here. So if you are in this lane and it detects that the priority or the fire truck's coming that direction, why not shoot a signal down to the next intersection and say, we need to preempt this? Saves you the cost of having an additional optical emitter at that intersection, but it's also a fail-safe for making sure that that vehicle does indeed get its preempt call. Transit signal priority routine. So again, I talked about using the priority functions within the controller to trigger priority events, and then using Opticom or whatever else. Same idea as a preemption, but lower priority, so to speak. Well, why not if you've got a certain bus that always runs late at a certain time of day, why not trigger based on time of day a priority routine where that transit vehicle is able to be detected by the traffic signal controller at intersection A, and then create a nice green band for it for the again up to 16 intersections downstream in order to make sure that bus gets to its destination on time and increase the schedule reliability. Stadium events, so another kind of real world use case for you guys. Good location to set up peer-to-peer. Some of you may be familiar, but the traffic around in the Seattle area is really, really bad when it comes to big events. Somehow in the city's in the development of the city, we ended up with two very large stadiums right next to each other. You've got T-Mobile Park, which is the home of the Seattle Mariners, and then you've got CenturyLink Field, and they're kind of crammed in here with a bunch of intersections that are really close to each other. So what I'm going to try and show you guys here is you've got a left turn movement this is a southbound lane at First and Royal Brougham, and a lot of vehicles are going to try and take a left turn here, and this is the view once you've turned left here on the right. They're going to take a left turn between the two stadiums, that's looking this way, and try and get either over to CenturyLink Field where the Seahawks play, or across this kind of spillway here to get to the Interstate 5 freeway that's across the way. The problem is these intersections are within 100 and 150 feet apart. it'd be a good use case for the city of Seattle to get those talking to each other and say, when there's a call or vehicles, you've got a platoon here sitting in the left lane, let's flush them through and make sure we're not backing them up onto Royal Brougham Boulevard here, potentially creating a dangerous situation, but mostly moving traffic through inefficiently. The reality is a lot of times they use policemen. Well, maybe there's a use case here for not needing to deploy a bunch of police on overtime, just by getting your signals talking to each other a little bit more. Another use case, city of Sunnyside. We've got to reach out to our friends there at Sunnyside, and peer-to-peer. It's been around for about a year and a half, maybe 2 years, in the Siemens controllers. The more I thought about it and putting this presentation together, I thought of a lot of actual real-world applications where we could really help the agency out. So essentially, what we have here, that area circled down at the bottom, is their traffic signal operations shop. What you don't see in this two-dimensional map view is that there's a lot of obstructions going between that main corridor there and the traffic signal shop. What we'd like to do is set up tactics and have a nice little central system. This is an agency of only 15 intersections, and we'd like to say, okay, well, here you've got the control at your fingertips. But after digging a little deeper, what we found is we've got this one corridor here. It's called Lincoln Street. It flushes over into Yakima Valley Highway, which is the main thoroughfare back to Interstate 90. So this is in eastern Washington. Again, if you're on the west side of the state and the east side of the state of Washington, it's night and day difference. Got a lot more grids as you get toward the center of the country, where we've got a lot more curvy, windy roads that don't make sense kind of in the Seattle area. Anyway, they've got this one corridor, and they're talking to us about what they wanted to improve and what they didn't like. The main takeaway was this Lincoln Way is not very responsive to the schools that are in the area. You've got pedestrians who aren't getting enough time across the street safely, and when you're talking about kids, that should be paramount concern for all of us, that we're not giving kids enough time. And then you've got vehicles that are backing up into school. It's taking forever to flush people on and off. And, this is a town of 8,000 people. So, potentially not a lot of patience for bad traffic. Well, even without being able to come up with a cost-effective way for them to create a central system, essentially we've got 4 major intersections, and each of them have a school near them. So, a solution for these guys is to shoot detectors towards towards where the schools are flushing or trying to flush people onto the street, and create a green band that moves cars efficiently. I'm going to recommend based on time of day. We're going to set this up around the school schedule and say, if we're starting to see vehicles, if the detectors are detecting vehicles at this time of day, we're going to flush. Coordinate these signals, get them all talking to each other, and flush the vehicles over to Yakima Valley Highway so they can all be on their way and not annoy everybody by backing up predictable every single day at the same time. So another potential use case that kind of circumvents having to go get a big federal grant or something like this. Over time, Sunnyside's just been adding traffic signals, or adding M60 controllers, and now with a little bit of communications between the two, I think they can accomplish a lot of the things that they would otherwise think would be cost prohibitive. And that's all I got. I appreciate you guys bearing with me. Hopefully that gave you guys some inspiration or some ideas for what you could possibly be doing with your existing inventory of Siemens controllers, or maybe you're not a Siemens user and you're just interested in the capabilities. Please reach out to us for any follow-up, or say, hey, give us a call, give John Brandon a call, give me a call and say, hey, here's my situation. Do you think peer-to-peer is a good solution for us here? And we'd be happy to walk you through kind of our thoughts on it. So again, thank you guys all for tuning in, and please enter any questions you may have.
All right, thanks, Kai. We'll get going on the Q&A. process. So if you have any questions, please use the chat feature within your GoToWebinar toolbar. All right, couple questions here for you, Kai. First one is, does peer-to-peer require a central system?
Yeah, so it does not require a central system. Peer-to-peer is utilizing if-then statements. So you can do that on a local level. Peer-to-peer just means two computers talking to each other. So that's one of the cool things. Maybe a complete central system or central system overhaul is years down the road and it's going to require some federal funding. But if you just cracking the nut of getting communications between two signals is generally a lot easier than saying, here's this large system we need. And so certainly, in short, no, you do not need a central system to run peer-to-peer.
All right, next one for you here. Does peer-to-peer require additional hardware?
So the functionality of peer-to-peer is built into the Siemens controller, given that it's Linux and running the necessary version of CPAC. You do need your intersections to be communicating to each other. That could be via fiber, cellular, broadband radio, like you saw in Coeur d'Alene. If they are close to each other, within 300 feet, you could run Cat5, kind of a shielded cable between each of them. But in terms of additional hardware, if you've got comms and you've got reliable comms, you're good. If you don't, we're not talking about a ton of additional hardware. All we'd recommend, putting in a rugged comm switch, a new switch, kind of planning for the future for all the IP addresses you might think are coming down the pipe. You actually can plug right into the controllers and get them talking to each other like that if you're on a shoestring budget.
Okay, that looks like all the questions we got today. So thank you everyone for attending today's presentation and have a great afternoon.